So the first thing I need to do is draw the diagram. So here's my roller coaster. It starts at the top of a 4-meter hill, goes down, goes back to a 3.5-meter hill. Okay, here's my object. It starts up there. It says it goes through a valley, and then it comes back up again. Okay, so there's my object. Coaster, 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 ramp. Okay, got it. Variables. So it tells me it has a mass of 0.5, so I'm just going to write that off to the side here. If I drew my picture a little bigger, I could write it on the object itself. Vincent, can you put your phone away for me? Thanks. Okay, so we're going to start with that up there, and then we're just going to label the other numbers. We got a 4-meter hill. We go to a valley, we go back up to a 3.5-meter hill. Well, write the right number. Good job, me. Okay. It says it starts at rest, so the initial velocity is 0, the velocity up here. And it says it doesn't know how fast is it going at the other spot, so I'm just going to write v equals question mark. So, drew the diagram. Drew the object, labeled the variables. There we go. All right. Next step, label A and B. So A is usually my starting point. B is usually my ending point. It doesn't have to work out that way, but that's usually what we'll do. The reason I label it A and B and not initial and final is because maybe B is at the bottom even though it ends up at the top. I don't want to go ahead and just assume it's the initial and final part, so I just label it as A and B. A is at the top of the first hill, B is at the top of the second hill. And I came with that just because literally that's what it tells me, right? Top of the second hill, here it is at the top of the first. That's where I got those from. Next thing, label a height as 0. You can use any height that you want. In fact, I'll show you that in a little bit. But let's go ahead and just start with the simplest one, which is the ground. All I do is I draw a dashed line and I write h equals 0. I have to know these things. If I don't know these things, there is no way for me to know that you did the problem right. Honestly, there's no way for me to know. Okay? Because if you said that the ground is 0, you're going to get different numbers than if you said the ground was 3.5. And I'm not going to go through all the math and say, oh, okay, well, what if they did? I'm not going to do that. Okay? I'm just going to say, I don't know what it is. I'm not going to grade it. I'm going to go on to the next person's. So I need to see this stuff. A and B, height of 0. Okay? And if you want to call the ground 0 every time, great. You don't have to move it around. You can leave it wherever you want it to be. So now we're ready to find the kinetic and potential energies for A and B. So the equations we're going to use are these guys up here. 1/2 mv squared and mgh. So the kinetic at A is going to be 1/2 mv squared. The mass is 0.5. The velocity is 0. 0 squared is 0 times anything is 0. So we get kinetic energy at A is 0. Okay, now I'm going to do the kinetic energy, or the potential energy at A, which is mgh. Mass is 0.5. G is 9.8 unless I say otherwise. Height is 4. And if you're wondering why I used the height of 4, it's because that's what I called A, the top of the 4-meter hill. So it's 4 meters above 0. And when I multiply that out, I get 19.6. Now I'm going to do the exact same thing for B. Kinetic energy at B. 1 half mv squared, so 1 half times the mass, which is 0.5, times its velocity, which we don't know, so we just write vb squared. Half of 0.5 is 0.25, and just leave the vb squared to hang around for the ride for right now. Now we're going to do the potential at B. mgh, just like before, 0.5 times 9.8 times the height. Now, B is 3.5 meters above the ground. And when I multiply that out, I get 17.15. So again, plug in the numbers where they go. Potential at A, or kinetic at A, was 0. Plug it in. Okay, potential at A was 19.6. Plug it in. Kinetic at B, 0.25 VB squared. Potential at B, 17.15. Get all the numbers to the other side. And once you've done that, 3.13 is the answer you'll end up with. So let me show you what to do if you don't make the ground 0. Now, you might be saying, why on earth would I not want to make the ground 0? Well, let me show you, and then you can be the deciding factor on what you want it to be. I'm going to make B 0. So I'm just going to draw a dashed line at B, and I'm just going to write B equals 0. Okay? Height of 0 is at B. So that's going to change some of these numbers a little bit. Instead of it being a height of 3.5 above the ground, it's at 0 at B. Instead of a height being 4 meters above the ground, it's going to be 0.5 meters above B. So I end up, let's go ahead and just redraw it just so we don't get confuzzled at all. So we end up with this instead. We end up with a height of 0 here. And so the height isn't 4 meters above the ground. The height is 0.5 meters above B. We're still sticking with our same A and B points. So now I'm going to find my potential and kinetic again like I did. But the numbers may change a little bit. So where they're the same, I'll just skip over it quick. And where they're different, we'll make a new change. So the kinetic energy at A. Still 1/2 mv squared. It's still a mass of 0.5. It's still a velocity of 0 at A. It told me that in the problem. It starts at rest. So it's still 0 at A. So this is still 0 joules. The potential at A will not be the same here. Okay, mgh, 0.5, 9.8. But it's not the height above the ground. It's the height above B now, which is 0.5. That gives me a potential of, I wrote it down, 2.45. Now we do the same thing for B. Okay? Potential at B has not changed. It's still 1/2 mv squared. We still don't know what it is for the velocity, so 0.5. The potential, or sorry, my bad, I wrote the wrong thing. This is kinetic, not potential. Now the potential at B. mgh, 0.5 times 9.8. But now, here's where the height gets interesting. The height at B is 0, because B is 0, which makes my potential at B 0. So, KE at A plus PE at A equals KE at B plus PE at B. So the KE at A is 0. PE at A is 2.45. KE at B is 0.25 VB squared. Potential at B is 0. Okay, we need to get the numbers to the other side. In this case, the only number is 0.25. That gives me 9.8. Square root both sides. And it's the same answer. 3.13, 3.13. So which way's the best way? Whatever makes sense to you. I do it this way because I like to make my numbers as easy as possible. And this is the easiest way to make the numbers simple. Notice I have 2 zeros that cancel out, and then I only have 2 values here to deal with. Okay? However, that's not the easiest to understand. This is the easiest to understand. Just always make the ground 0. Perfectly fine. You get the same answer either way. The math's a little trickier, but not that much trickier. I mean, we have 1 extra number, but that's not a big deal. The 3 places that make the most sense to put 0 for the height are A, B, and the ground. Those are the 3 that make the most sense. You can do anything, but A, B, and the ground are the ones that make the most sense. Okay? Just depends on what you're trying to do. Also, you don't have to solve it twice. I solved it twice to show you what changing the height does. But you don't have to solve it twice. Okay? You just have to solve it once.